Okay, Section 1.1, Introduction to Algebra, Variables, and Mathematical Models. All right, evaluating algebraic expressions. We can replace a variable that appears in an algebraic expression by a number. We are substituting if I could spell, hopefully that's right. I cannot spell. Substituting the number for the variable. This process is called evaluating the expression. So you're going to perform all operations within grouping symbols such as parentheses or square root symbols. Do all exponents. Do all multiplication and division in the order in which they occur, from left to right. And same thing with addition and subtraction. You do whatever comes first, left to right. We know this as PEMDAS a lot. Parentheses, exponents, multiplication, division, add and subtract. I always circle them because it doesn't mean that multiplication always comes before division. It just whatever comes first. We had to write something first. Same thing here. Sometimes we're going to add first. Sometimes we'll subtract. It just depends on what comes first in the order. All right. Evaluate each algebraic expression for x equals 5. What we're going to do is we're going to take this x out and we're going to replace it with 5. So we're going to say 3 plus 4. This stands for multiplication. I just use parentheses. I substitute it in like this. You can do a multiplication dot. You can do a times symbol, whichever one you want. This is how I do my multiplication. So 3 plus, we don't have any, well, we have parentheses. We just have that for multiplication. There's nothing we can do inside. We don't have exponents. We do have multiplication and division. So we're going to do this first. That gives us 20. Now we're going to say 3 plus 20 to give us 23. Right here, we're going to take that x out and we're going to put in a 5. We're going to substitute it. Okay, in our PEMDAS, we do have parentheses, so we do that first. Inside these parentheses, that gives us 8. So you say 4 times 8. You can write it like that. Using the multiplication dot, you can use the x or you can use parentheses, anything you want. This time, I'll use the multiplication dot. Why? I don't know. It doesn't really matter. You just need to know that it means multiply, and 4 times 8 is 32. By the way, this first section, or the first chapter test in chapter 1, you will not be able to use your calculator. So when you're doing your homework, get used to doing things without a calculator and on paper. Even though you're going to be doing all your homework on a computer, you should always have notebook paper and write the problem down, work it as if it was in a book. Then, just like here, if this had been on the computer, I'd written it down on my paper, I'd work it, get the answer, and then plug it in. Okay, right here, and we're not going to we may or may not do the practice problems in this just for time purposes, seeing we are a few days behind. Okay, here, we're going to take out the x, and we're going to now make it a 10. So it's 6 plus 2 times whatever x is. In this case, it's 10. We're going to multiply before we add. So 2 times 10 gives us 20 plus 6, and that gives us 26. Right here, I'm going to take that x out, and I'm going to put a 10. We have parentheses. We do parentheses just from up here, parentheses, then exponents, multiplication, division, add and subtract. So parentheses is first. That gives us 16. So 2, if you want to use the times symbol, it's fine. The only reason I don't like to use it is because the difference in an x and a times, sometimes it just gets hard. So I rarely use it. I will show it, but I rarely use it. The difference, though, for my times, that's a times. My x is going to be kind of like this curvy looking thing. So, okay. Next page. And we won't go over every single problem in here. It's just an introduction. So, okay, now they're getting a little bit more difficult, only where they give you two variables. X is 6 and Y is 4. So you're going to say 5 times whatever X is minus 3 times whatever Y is. I just did it that way because I have to switch pens. X in this problem is 6 and Y is 4. So now, following the order of operations, we're going to we have multiplication, subtraction, multiplication. So we're going to multiply first. And you can do this in one step or two. So this gives us 30 minus 3 times 4. And I could have done this at the same time. I'm still going to multiply before I subtract. 30 minus 12, and that gives us 18. Now again, I could have skipped this step here and just said 30 minus 12 to give us 18. Okay. Right here, this one's a little bit different in the fact that before you can do this division, you have to get the answer on the top and you have to get the answer on the bottom. So we're going to say 3 times whatever X is plus 5 times whatever Y is plus 2. X is 6 and Y is 4. All over 2 times whatever X is minus our Y. So our X is 6 and our Y is 4 still. Okay, now I've got to simplify the top first. This is so thick it won't stay down. So I'm going to go ahead and do this multiplication, gives us 18, plus this multiplication gives us 20, plus 2. On the bottom, I'm going to do this multiplication that gives us 12 minus 4. Now I can add on the top, and to make it easier on myself, I'm going to say 18 plus 2, which gives me 20. 20 plus 20 is 40. 12 minus 4 gives me 8. And now I can divide and get 5. Okay, I'm not going to do this practice. This right in here, I'll do a few of these. The main thing that they're trying to get you to know is these words, okay? When you see plus, sum, more than, or increased by, it means addition. Subtraction can be minus, the difference, less than, decreased by. Multiplication can be times, product, twice, multiplied by. And then division is divide, quotient, ratio, or divided by. These are the key ones that a lot of people may not know. And you'll see those a lot. It's not to say that you won't see the others. It's just those are the ones that kind of hard to figure out sometimes. Okay, the sum of a number and 7. Okay, when it says a number, we're just going to use any variable we want. But in this case, it tells us to use X. Okay, if it didn't do that, you could use A, B, but it tells us to let the variable be X to represent the number. So the sum means addition. So you would just write this as X and a 7. Okay, sum of the number and 7. 10 less than a number. Be careful when you see the words less than. That means you take the number and it's 10 less than, so it's subtracting 10 from it. Okay, be careful. These words, I don't know why I did that, but these words here, this number comes after the subtraction sign. Okay, twice a number means 2 times a number. We represent that as just 2x. You don't have to use the multiplication sign. If multiplication is the only thing that can be invisible. Okay, so if I don't see an add, subtract, or divide sign here, then I know it's multiplication. Then decreased by means subtraction, 6. The product of 8 and a number. Well, product means multiplication, so it's just 8x. 3 more than the quotient of a number and 11. Now you can do this as two different ways. You can take more than means addition. It doesn't really matter about multiplication, addition. It does matter the order for subtraction. So you can have 3 more than, so 3 plus. The quotient means division of a number and 11. So I'll always write my division this way. Or you could write this as x divided by 11 plus 3. I just like it this way, but it doesn't matter. This is more the same type, so I'm not going to really go over that. Right here, a blank is a statement that two algebraic expressions are equal. An equation has an equal sign with something on the left and something on the right. Okay, so these are equations. What we want to know is determine whether the given number is a solution of the equation. So when we substitute this number in, does the left equal the right? If it does, it's a solution. If it doesn't, it's not. So what I'm going to do is I'm going to say 6 times my x, which is 5, plus 16, and if it's a solution, it'll give us 46 on the left side. So I'm going to follow my order of operations. I'm going to multiply first, and I get 30 plus 16. So on the left-hand side, I get 46. Well, I have 46 on the right-hand side. So the left equaled the right. So it did check out. So yes, it's a solution. Okay. I'm just going to put SOLN. Now let's do 5 is. I kind of did that backwards. Why, I don't know. I was just going to put, let's just put solution. Okay, you know that 5 is a solution. Okay, up here, wherever I see a Z, I'm going to put a 7. Hold on. Just takes too long to keep switching pins. All right, so Z, so it's 7 plus 1. In here, I'm going to have 7 minus 2. Okay, so if 7 is a solution, the left will equal the right. So I'm going to do parentheses first. This gives me 8. 2 times 8. Right here, parentheses first, that gives me 5. So on the left side, I have 16. On the right side, I have 25. So the left is not equal to the right, so this is not a solution. And you do the same thing down here. All right, so now we're going to write equations. So that means we're going to have equals so-and-so. So it says the product of 6 and a number. Well, we already learned that product means multiplication. To write the product of 6 and a number, it's 6x. Is stands for equals 30. Be careful, the words less than. That's the ones that you got to be careful about. 7 less than 3 times a number. That means you take 3 times a number. Again, it told us to use x. Less than means subtract 7. Gives is the same thing as equals 17. Usually it'll say is, but okay. I'm just going to show you this. I think I took these out of your homework. If not, you have like one at most. When translating English sentences containing commas into algebraic equations, commas make a difference. This here says the product of 6 and a number increased by 5 is 30. So this one here, it says the product of 6 and a number increased by 5. That's why you have to use parentheses here. Now these get kind of tough. It just takes practice. But again, it's not going to be on your test, and you might see 1 or 2 in your homework. But now when we put a comma, it says the product of the product of 6 and a number. This is where you say 6x, because that's where it stops. Increased by 5 is 30. This up here says the product of 6 and a number increased by 5 is 30. That's why we have those parentheses. Okay, so right here, the quotient of a number and 6, that would be, quotient means division, stands for equals 5. Right here, 7 is decreased by twice a number. So decreased by twice a number yields, weird word for y'all, means equals 1. And I'm going to skip this last word problem. All you're doing is substituting things in. Okay. 1.2, fractions. This first test, you're not supposed to use a calculator. And when we get back to class on Monday, I'm going to think about what we're going to do over the weekend as far as this is concerned, because this is always a tough thing because of fractions, okay? So, anyway, a mixed number consists of the sum of a natural number and a fraction expressed without the use of addition sign. So basically, you got a big number and you got a fraction. Okay, this means 3 plus 4/5. We just don't write the plus sign in there, but we read this as 3 4/5. An improper fraction is where the numerator is bigger than the denominator. These two are equal, okay? The reason how you figure this out is you just take 19 and you divide it by 5. So we are going to have to do division without a calculator. Do not use your calculator on your homework. You can, but you're going to be tested without it. Okay, so that's why you should always practice without it. Okay, how many 5s will fit into 19? And that would be 3. So 3 times 5 is 15, and we subtract and get 4. This is your whole number. Okay, so it's 3. This is your numerator. And this is still your denominator. Let's call this, let's call it the big number. Or the whole number, okay? So it's 3 4/5. All right. So now we're going to go backwards. Convert. I mean, they may explain this later on. I don't know, because I don't really pay attention to what these notes do until I'm going through them. Okay. If we're going to convert this to an improper fraction, what we're going to do is we're going to take these two and you're going to multiply. Then you will add the 2. So you're going to say 7 times 5 is 35 plus 2 to give you 37 over 7. Your denominator still stays the same. So you multiply these two and add this to get that top number. Okay, right here, your denominator stays 8. Okay. To get your top number, you multiply 8 times 2. I don't know. 8 times, see, that looks like a plus sign. Let's use the multiplication dot, I guess. 8 times 2 is 16, plus 5 gives us the 21 over 8. And this is known as an improper fraction because the top number is, the numerator is larger than the denominator, or your top number is larger than your bottom number. Okay, so now we're going to convert back to a mixed numeral, which I just showed you. So you're going to take 5 and you're going to divide it into 42. Okay, 5 goes on the outside. Okay, and it doesn't, well, everybody thinks the larger number always goes on the inside. That's not always true because when we get to decimals, you'll find that out. But for now it is, but I wouldn't learn it. The top goes on the inside. You are dividing, the denominator always goes on the outside. So 5 goes into 42 8 times. 8 times 5 is 40, subtract and get 2. So it is 8 and 2/5. Right here, 3 goes on the outside because that's what you're dividing by. Even though we read this as 5/3, you also could read this as 5 divided by 3. I don't know why I made that division sign so long. But 3 will go into 5 one time. 1 times 3 is 3. Subtract and get 2. So it's 1 and 2/3. Factors and prime factorization. Okay. Factors are numbers that multiply together to give you the number. Like the factors of 21. You can get 21 by saying 7 times 3 or 3 times 7. And 1 times 21. So the factors of 21 are 1, 3, 7, and 21. You always put it in order. That way it's just easier so everybody can check it. Okay, a prime number is a number greater than 1, and the only way you can get it is 1 times itself. So the first 10 prime numbers would be not 1 because it cannot be. They have to be different factors. 2 is our first one because the only way you can get 2 is 1 times 2. 3 is our next one, 1 times 3. 4 is not, okay, because it says the first 10. So 4 goes down here, okay. 1 isn't prime or composite, okay. 5 is next. The only way you can get 5 is 1 times 5. I don't know why my numbers are getting big and small and whatever. 6 is composite because 2 times 3. 7, the only way to get 7 is 1 times 7. 8 is down here as composite. 9 is composite. 10 is composite because 2 times 5. 3 times 3. 11, 12 goes down here because 2 times 6 or 3 times 4. 13, 14, 2 times 7. 15, 3 times 5. Let's see, we're only supposed to do 10. 1, 2, 3, 4, 5, 6, 7, 8. 16, 4 times 4 or 2 times 8. 17, the only way you can get 17 is 17 times 1. 18 is down here. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. 19 is up here. 1, 2, 3, 4, 5, 6, 7, 8. We need 2 more. 20 would be a composite. 21, 3 times 7, so it's composite. 22, all even numbers are going to be composites because 2 goes into it. 23 goes here. The only way we can get 23 is 23 times 1. 24, 25, 5 times 5. 26, 27 is 3 times 9. 28, it's even. 29 is the last of the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Notice all the even numbers are down here. Prime numbers are all odd except for the number 2. Okay. So, all right, that's prime and composite. And 1 is neither. Because I think it says it's a natural number. No. Yeah, it says natural numbers greater than 1. Okay. Find the prime factorization of 100. Okay. Every composite number can be expressed as a product of primes. So we talked, you probably have seen the factor tree. So I'm going to do 100. Now, we're going to split up 100 however you want to. You can do 2 times 50, you can do 4 times 25, you can do 10 times 10, 5 times 20, however you want to. I'm going to do 10 times 10. Okay. 10 can be split up as 2 times 5. This 10 can be split up as 2 times 5. Now we have all prime numbers, so just put them in order. 2 times 2 times 5 times 5. Oh, I don't know, but that's probably, yeah, that's how they did it. You could put 2 to the second power times 5 to the second power. It's the same thing, but I'm just going to leave it like this because that's what the example above did. Now, I told you could split it up differently, right? You could use, the reason I don't like to use 2 is because my factor tree gets longer or taller. 2 times 50. 2 is prime, so I bring it down because a lot of times people will, if you just leave it up there hanging, you forget about it. So here, let's do 2 times 25. 2 is prime, bring it down. 2 is prime, bring it down. And 25 is 5 times 5. So you still will notice that you get that. So it didn't matter how you did it. Like 36, you can split it up as 4 times 9. You could do 6 times 6. You could do 2 times 18. I'm just going to do 4 times 9 because that's what I said first. 4 is prime. I'm sorry, 4 is composite, so you can split that up as 2 times 2. And 9 is 3 times 3. Now we have all prime numbers. So the prime factorization for 36 is 2 times 2 times 3 times 3. If I multiplied those out, it would give me 36. Okay. Reducing fractions. Okay. They use reducing fractions. They do the prime factorization of each numbers. Okay. If you get stuck, you can always use that. I'll show you both ways. I pick the biggest number or a number that'll go into 6, that'll go into 14, and that is 2. So I divide the top by 2 and I divide the bottom by 2. Now if there's a bigger number, I choose it. 6 divided by 2 gives us 7. 14 divided by, I'm sorry, let's try that again. 6 divided by 2 is 3. 14 divided by 2 is 7. So it reduces to 3/7. If you did the prime factorization for these, prime factorization for 6 is 2 times 3. Prime factorization of 14 is 2 times 7. Well, 2 times 2, or 2 divided by 2, that there gives us 1. Okay, they show it this way. 2 over 2 times 3 over 7. Well, this reduces to 1, and 1 times 3/7 gives us 3/7. Now, that's a lot of work to get there. I don't care which way you do it, just figure something out. Like right here, I know 5 will go in. I may have to reduce